Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 2. We're on problem number 24. So in this problem we're told that there's a vertical fence whose base is this curve y equals x root x from 0, 0 to 1, 1. And the height above each point along the curve is this function x cubed minus y squared plus 27. And then we need to find the area of the fence. Well, the area of the fence is just going to be the contour integral. Area is the integral. So I'll just remind you that when you're taking a contour integral along some contour C of some function where the differential is a little bit of that contour, ds, then you want to convert everything to a regular integral in some parameter t. And the way to do that is to parameterize the contour and then substitute in for f of xy turn it into a function of t. So I'll show you how to do that. In our case, the curve is the function y equals x root x. And in order to parameterize this, we have to write x as some function of t and y as some function of t. So we have to decide what our t is going to be. And sometimes you can just write t equals x, but here to avoid all these square roots, I'm just going to write t equals the square root of x. That way I won't have square roots in my parameterization. And that means that x is equal to t squared, which means that y is going to be t cubed. And now I can write this contour as t going from t is going to go from 0 to t equals 1. Okay, and now I just need to figure out what my ds is, and I'll remind you that ds dt is going to be the square root of dx dt squared plus dy dt squared. Okay, so that means that ds dt is equal to, let's see, what's dx dt? That's the derivative of x with respect to t, so that's going to be the square root of 2t squared plus the derivative of y with respect to t, and that's going to be 3t squared, and we have to square that. Okay. So what do we get? We get the square root of 4t squared plus 9t to the fourth. We can factor out a t squared, and that'll give us a t times the square root of 4 plus 9t squared. Okay, so this is our ds dt. Yeah, I'm just going to remind you, this is equal to, I'm going to write it, ds dt. Okay, so in our integral, we can replace ds with this quantity times dt. So this integral is going to be the integral from t equals 0 to 1. And now f we're going to write in terms of t. So our function f, instead of x cubed, we're going to have t squared cubed, which is t to the 6th minus y squared. So instead of y squared, we're going to write t cubed squared, which is again t to the 6th, so that's going to cancel out, plus 27. Now instead of ds, we're going to write this quantity, t times the square root of 4 plus 9t squared dt. That's our integral. Now, we're pretty lucky. This t to the 6th and minus t to the 6th are going to cancel out. 27 is just the constant, so that's going to come out in front. So we're going to get 27 times the integral from t equals 0 to 1. Now, I'm going to do a little substitution here. I'm going to say u is equal to 4 plus 9t squared. which means that du is equal to 18t dt. That way the t's will cancel out, and our integral is going to be 27 over 18 from this 18 here. The t is going to cancel out with the t, and we end up with the square root of u. This whole thing here is u and du. Okay, so what do we get? 27 over 18, that's just 3/2. The integral of the square root of u is going to be, I think, 2/3 times u to the 3/2. And we're evaluating this, well, we can change our limits of integration. Instead of t equals 0, well, what is u going to be? When t equals 0, then u is going to be 4. And when t is 1, that means that u is 4 plus 9, which is 13. So this gives us, well, let's see, 3/2 and 2/3 are going to cancel out. So we end up with 13 to the 3/2 minus 4 to the 3/2. 13 to the 3/2 is the same thing as 13 root 13. And 4 to the 3/2 is the same thing as square root of 4 is 2, cubed is 8. So our answer is 13 root 13 minus 8, which is answer D.